Today I want to do a review and we're going to do the past papers on it, right? Right, so let's take a look at the review. What are the different types of op-amps again? Inverting, non-inverting, and cascade, not cascade, but when they combine them. One missing the first one. Huh? No, someone is an example of the comparator. Nice. So for the op-amps, we need to remember that, right? So for the op-amps number, I want to remember what the op-amp is. Op-amp, right? It takes a small input and gives a large output. Right? Remember the op-amp looks like this. Right? The op-amp looks like this. You have two terminals, negative, positive, connected to Earth. Right? Here might be a VN. Actually, let's leave both of them, right? This is the inverting terminal. This is the non-inverting terminal. You have your supply. And you have your negative supply. And you have your output. Right? Some of the basic things that we need to remember. You need to remember gain. What is time gain again? Gain is V out over V in. Wait, I don't get it. V out and V in, right? Yes, sir. Next, we need to remember what's the maximum value for V out? Positive VS. And what's the minimum value for V out? And if it's outside here, it's called what? Saturation, right? What it is really controls saturation. Anybody remember? What it is really causes a pump to go in saturation. Overload. Yeah, what causes the overload? High input, right? So based on where your input is. And how you find this again? Maximum input is what? Right, rearrange. Plus and minus BS over the gain. Okay? Generally, what does the graph look like? What does the graph of V out versus CN look like? Kind of Z, right? So you have a straight part here that can help you find gain. And then you have a plateau here and a plateau here. What do you call here again? What is called that plateau part? The what? Saturation. Right? So here is your negative VN. Here is your positive VN. Here is your positive VS. Negative VS. Right here, a way to remember is your saturation. All right, then too small. But let's get our next marker. Right? Copy that down. Copy that down. Let's change it. Right, now let's look at the types of done. Right, when you finish, we got the types. Oh, by the way, I forgot to squeeze in the assumptions. What are the three assumptions of the op amp again? Are doing ideal, right? The open loop is what? Infinity. So gain is the largest possible value, infinity. How do they achieve that? Anybody remember? Input impedance is what? What are writing worse in this? Input impedance and output impedance. Think about the principle, right? For you to get infinity and then divide by zero, so the input have to be what? Real small. So how could you make the input resistance small? How you can make the input small? If the resistance is what? High or low? High. And how you can make the output large? Low. Okay? So those are your three assumptions for ideal op amp, right? Ideal. I gave you all for the others as well, right? Typical. I just doing a summary here, right? So I'm gonna give you all three, we'll draw them and give a general thing on each one, right? Ready? Right, now, three types of op-amps. They are what? Comparator, inverting, and non-inverting, right? So let's start with the, why this thing? Let's start with the comparator. What does the comparator do again, Fishish? Vinay. What does the comparator do? Right, it compares, right? It compares. So it takes the inverting value and compares it to the non-inverting value. If the inverting value is greater than the non-inverting value, what will happen? It will saturate low, right? I'll give you the lowest possible value. If the V non-inverting is bigger than the V inverting, it will saturate high. That's okay? Yeah? Then we have inverting op-amp. What is special about the inverting op-amp? Is invert. Very good. Sit up. Very good. Very good. Well, something else about it. Which one grounded? Right? So the positive or the non-inverting grounded. Something else. It has something. It has feedback. Right. It has feedback, right? So you have a feedback resistor and an input resistor. Anybody remember what the feedback does? What does the feedback do? What does feedback do? Must run up there double time. Yeah. Anybody remember this? Anybody remember? What does feedback do? Online, anybody remember? Feedback does something. I'll give you something else to help you remember. What does feedback do? No. It drop the gain. So yes. So whenever you have feedback, you end up dropping your gain. And if you drop your gain, you will increase your bandwidth. Okay? So when you drop your gain, you increase bandwidth. Bandwidth means the range of frequencies. Right? Nice. For the inverting op-amp, what's the formula for gain again? Gain is what? Huh? No, for this, what specific formula we prove? Minus RF over. Don't forget the minus, right? Why minus again? Because it's a inverted, right? Non-inverting. Non-inverting, we have the input here. Huh? Let's join us there for you. Remember the inverting terminal connected to Earth. What's the formula? What's the formula for gain here? V out over. No, for this one. That's a general formula, yeah? RF and RI plus 1. Plus 1. That's the proof. We did this last week. right? Nice. And just some quick things to remember whenever you have cascade, right? Multiply the gains. Okay. So this is technically summary here of your op-amps. Right? These are all the things that we did for the past couple of weeks. What we're going to do now is we're going to do the past papers on it. We kind of did some already. And then next week we wrap up module 2. Right? For those who remember doing module 2, module 3, then module 1. Yeah, I can try to the what I would say to it. Voltage follower seen as what? Summon amplifier, cascade gain. That's like when you have two op amps together, they multiply the gains. Ready? Be output voltage ada. Right, answer. Right, so we're gonna start with one, right? Someone ready? Is that ready? Ready? Let's start, right? So we're trying this here, 2023. I want to show you if a full logic gate, a full up-arm question come, it can look like this. Right, let's start here, 2023. Right, what kind of up-arm we have here? Ready, Paul? Right, Jacob, there you go. What kind of up-arm we have there? What type of up-arm is that? Inverted? What? No. What should the name in the description? A comparator, right? So you have two inputs here, V1 and V2. You have your V out, positive V supply, negative V supply, and positive input, negative. Everybody give it up? Watch the diagram closely earlier. The positive on top, right? Negative underneath, right? They just switch it around. My diagram is the other way around. They're ready, marker. Okay? Right. So here we have an up-amp comparator. So basically, this whole question is about comparing V1 and V2. Okay? So that's exactly what we have here. Everybody okay with that? Right? So let's see what they're asking us first. Write an equation. Write an equation to show the relationship between V out and the inputs V1 and V2. Write an equation to show. Really an inequality one. Write an equation to show the relationship between V1, V2, and the output. Writing it is structure. Second mark. Marks. Mark is out. Mark. That's it. That's your method. Oh yeah, try that again. Write an equation showing the relation between V out and the inputs V1 and V3. Right? So you're basically writing this.
But you only two to show it.
Huh? Well, there's a next way you can write it, and I can show you. Well, it would help you find the value, but here what you could also write. Oh wait, I can write here. What you can also do is write it from here. Right? But it's not going to help you explain how it works. But here's what you can also do. You can write, remember gain is what? V out over V in. Right? So V out is gain by V in. You'll see now? Right? So what you can also, one way you can write it is this. Gain multiplied by V1 minus V2. Right? That could up. Oh, sorry. You could also write that. And but here's what you have to say. You have to say when V1 minus V2, what's it here? When V1 minus V2 positive, right? V out is what? V out is what? Positive Vs or minus Vs? What's it good? V1 is going to which terminal? Positive. So if V1 bigger than V2, then V plus bigger than V minus. So therefore your output will be the maximum, right? Positive Vs. And if it's negative, it will be minus Vs. So this is one option, but I prefer if you write this because part 2, using the equation, explain how the comparator works. Okay? It's easier to explain from this. Use the right letters over there. They have V1. V1 is V non-inverting. V2 is V inverting. Okay? Right up these and explain how it works. Chemistry. Right? Can I change? Next time. Okay, action. Okay, all done? Yeah. Are you finish up? Yeah. Jacob, you done? Next part. Try that, please. Dash. Try this.
So I'll try.
Right? Highlight the important things they give you, right? They give you the gains. They give it positive and negative VS. They told you give you a negative voltage output. They want you to find the change in the input.
So is the same one?
Same question,
Same surgeon.
same sir.
Fine.
Yeah, it's like very good understanding. All right. Take your time. Right, number one, they ask you for input change. Delta V is the change in input, positive P plus, sorry, P plus minus V minus.
How you just cut?
So you have to figure out how you're getting that. I'll help with us now.
So.
Yeah. Huh? 10 to the 6. Right? VS of plus and minus 5 volts. Right? Remember, I just gave you this, right? I just gave you a little formula of V out is being by. See if it helpful. If it's not helpful, I'll help with us now. Until you are done. Okay. Right, remember that you can call that delta V, right? Right, time up. So it should be done by now. So day one delta V. Delta V is basically V out on gain. Right? Your V out, the question said a negative voltage. So that will be -5. And the gain is 10 to the 6. So the difference in the inputs will be -5 by 10 to the power -6 volts. Yeah. Yeah. -6, right? How much you get? -5 or -6? Right, yeah. -5 times, oh shucks. Sorry. And how we are gonna say it. I divide V out by the gain. Right? So -5 divided by 10 to the 6 is -5 by 10 to the 5. Right? That's the difference there that we call saturation. Copy down, let's go again. All done? What you see, we gotta explain all your added zoom out, right? So I'm gonna take a pic to see it. 23. Yes. Okay, when any group night again. Right, I'll share it. In the group, I can take a pic and take a read of it. What kind of apartment have Jacob? Because you only talking, so I call you on Chinese. Chinese asking you after. Asking you first. Tell me. What kind of pump is that? And have the examples on the board. A comparator again, right? Good. So you have to explain how that works. We did a lot of calculations like that earlier. The question is, explain how the circuit in figure 4 will function to trigger the alarm if the temperature drops below the threshold value. So let me see if you remember how these circuits work. Looking like no, but let's turn back at one example. Look back at when we did this, the comparator. I'll explain it just now, but try to explain how it will work. Question. For the alarm to go off, V out has to be positive or negative. V out is positive 10 or negative 10. Positive, like a 1. It's like a 1 would trigger it. 1 is on, right? So you have to make your V out. You have to make your V out positive 10 volts. It's a comparator, right? How do you make V out positive? Which one has to be larger? Which one has to be larger to make it V out positive? Right, the non-inverting, let me be specific here. The V plus must be bigger than the V minus. What's that? They want to explain how the circuit in figure 4 will function to trigger the alarm if the temperature drops below the threshold value. There's a thermistor here. But even if you can't explain how the thermistor works, you should be able to explain what will cause the alarm to go off. That's why I help you with it. Try something, I'll give you 5 minutes. Ready? Jacob, what are you doing, boy? Very try look up on your phone, boy. Online, you want to do it? So I'll give an explanation just now, right?
Set the clock.
Set, you know how many set?
See you school boy.
Yeah,
Yes, set the set. So accept the answer to the question. It's not the
What's that?
What's that? Set. I guarantee you the answer to the question in a
Set it there?
Yes, sir.
All right, let's go. We're taking a little too long, right? So, how are we going to explain it, right? We start with number 1, right? I'll give you a word thing just now, but what causes the alarm to go off? V out has to be more. That makes sense?
Yes.
Sorry, V out has to be positive 10. Positive 10 acts as on. That's okay? Nice. How do we achieve positive 10? V positive must be greater than V negative. That makes sense?
Yeah.
Right. So, what does the thermistor do to create that? By the way, before I forget, what type of circuit is that? What type of circuit is this? Parallel circuit. No, our next name I'm looking for. When you have 2 resistors in series,
Oh.
it's called a 2 resistors in series. P and D. Potential divider.
Oh.
Right? This is the potential divider circuit. Right? How do you find the potential? Simple. V is equal to V out by R1 over R1 plus R2. So you may or may not remember is this will be a R1 and this will be a R2. Right? So when your R1 value changes, right, it will change in such a way that it makes the V plus value bigger than the V minus value. Because remember, R1 is a thermostat, right? So your thermostat changes based on what? Change in what? Temperature. So when the temperature drops below a threshold value, right? Then your resistance of your thermistor will change so that your V plus value is bigger than your V minus value. Right? We don't have numbers, so we just generalize them what will happen. Sorry? When it's based on what? It's based on what type of thermistor they specify. So the ones that we generally use are negative coefficients. Remember what negative coefficients are multiple. Negative coefficients means as the resistance drop, or for example, temperature. The other way around, temperature is rise. Okay? And the other way around. As the temperature rises, resistance will drop. As temperature drops, resistance will rise. Okay? It's called a negative coefficient, so that they behave inversely. Alright? But the question didn't really specify, but ones that we use are negative coefficient. Alright? So take this small explanation down. Hold on, let me just make sure I have everything. An intern at an aircraft manufacturing firm was told to prevent icing of the aircraft's wings during cold weather. The temperature of the wing should never drop below a certain value. She designed a simple comparator to trigger an alarm if the temperature of the wing dropped below a threshold value. Right? So whenever R1 drops too low, sorry, would the resistance drop or go up? Right. So if R1 goes above a certain value, it will trigger V plus to be larger than V minus, causing the output to be saturated high and turn on the alarm. You okay with that? Yeah, I'm gonna give you the note now. Right? I'm gonna give you the note now. Ready? When the thermistor experiences a temperature when the thermistor experiences temperature below the threshold value it will cause the resistance of the thermostat to increase. It will cause the resistance of the thermostat to increase. Right? It will cause it to increase. Full stop. This causes the potential, full stop. This causes the potential at the non-inverting terminal. This causes the potential at the non-inverting terminal. I'll take it out. To be more than the voltage at the inverting terminal. To be more than the voltage at the inverting terminal. Hence, the output will be, hence, the output will be positive 10 volts. Triggering the alarm to go off. Triggering the alarm to go off. Huh? Saturation. Yeah, and trigger the alarm to go off. Okay, up. You will take off the alarm, then you just make B minus bigger than. Okay, but again, that is the assumption that is a negative coefficient of thermistor, right? If it's positive, then the other way will happen, right? Yeah, I think 8 mark. Right, but of course, in between you can just write what I have there in red. Right? If B plus bigger than B minus, you'll get B out of that, right? Adding those things in red. 8 marks to that. And then there's a nice calculation after. Right? Remember, you know, how the comparator works, right? Comparator compares the input. So it will cause, if the negative coefficient, it cause it to decrease. And that is that increase will cause it B minus the either go. Right? Last part. Right, this up. Last part. Calculate the overall gain. Calculate the overall gain. What type of circuit is that? Jacob? Cascade. Who writing it? Wait, is that the time already? Yeah, there's the last one before. Are you done? Finish? Oh yeah, work out the overall gain. Sorry, sir. Right, we have two up arms. Up arm one and up arm two. Chinese. Up arm one is what? Man, tell me that man name, yeah. You are that Christian. What type of up arm is the first one? Non-inverted. And what type of up arm is second one? Not looking like input. Go ahead. Work out the gains. Sound like good? Fire to the back there. Big chocolate. Huh? Going to what time? Yeah, wait. Atilia, can you probably have a good question please online? Or like you send an answer for this, please?
Yeah, I can tell you if something. Right, anyway.
How much you all got? 55. Let's see. So the gain for the first one is 45 over 10 plus 1, right? Non-inverted, right? So that is 5.5. Next one is what? 60 over 10. Sorry. 60 over 6 with 10. So the overall gain we just have to multiply. Right? Gain of 1. Right? Oh yeah, minus 10. Thanks, Judah. So that's gain of 1 by gain of 2. So that will be 5.5 by minus 10. Hey, and we're going to go for free.
Okay. Go ahead.
A mixed product kind of.
So, go on over there.
No, I think. Huh? Now I have a dog may pop in the road and take the dog. But I'm gonna give it the female give her trouble. Can't go on them, no? Alright, let's go again. What is meant by bandwidth? Range of one word missing. Bandwidth is what? Range of that the upper would operate on. So range of operational frequency. Right? Range of operational frequency. Alright, this one might be kind of hard to do because for the class yet. Alright, I'm gonna give you an example here, right? Suppose they said to read off the bandwidth when the gain is 40. I will read it off here because it's kind of hard for you to see. Right? If the voltage gain is 40,
Well, this time 24.
right? What you have to do is come across here and come down here. And the bandwidth, the bandwidth will be 1. You want to start at 1, right? Or in this case, 10 to the minus 1, 2, 10 to the 4. Okay? You must give them the full width here. All right? All right, you cannot change this scale here. I just wanted to show you how to read up bandwidth, right? One more. Huh? This one is a past paper. You can pick up it now. We'll use one together because time kind of running out, right? I want us to do all this next one here. Right. Let's do this together. Let's start with finish. What type of pump is that? Non-inverted, nice. First thing they ask you to do is to show this. Remember the proof I showed you all? Right, so you have to write that over, right? Next part, they gave you RF, right? The value, if you can't see, RF is 440. 440 kilo ohms. R1 is 40 kilo ohms. And the operational PS is plus and minus 5 volts. Right, let's start one time. What's the value of the output when VI is 250 millivolts? I find output again. Sorry, somebody say that. Gain by Vn. Can you find the gain for this op amp? Did you find the gain for the op amp? Yes. What's the formula again? Sylvester. What's the gain for this op amp? RF.
Yeah. Or
Plus 1. So RF is 440 over 40. How much you get it? Do that mentally fast. How much? 12, right? 12. Till you're seeing 11 here. Gain is 12. Work it out fast. So that'll be 12 multiplied by 250. But I convert in one time. Are you okay with that? I convert in one time, right? 0.25. So your V out is what? What is 12 by 0.25? 3. Is that saturation, Jacob? The answer for the output is 3 volts. Is that saturated? No. Right? Nice. If the op amp if the op amp is not to be saturated, what is the maximum voltage amplitude for the input? What are they asking us to find there, Ash? Part 2. What are they asking us to find in part 2? What is the value of the output voltage? Sorry, that's part 1. If the op amp is not to be saturated, what is the maximum voltage amplitude for the input signal? Huh? I gave you a formula that was not called saturation.
Oh.
It's on the board.
Yes, no.
Yeah. You want the bottom here. Plus and minus Vs divided by the gain. What's Vs again finish? 5. Plus and minus 5 over the gain is 12. Okay, you can leave it just like that. You guys have a sketchy graph?
No.
I think we can sketch a graph quick. Sketch a graph to show the expected output when the input is 0.25. I don't think anybody could remember what is happening in this graph. Something happens in this graph. The amplitude of the input is 0.25. Is what? Yeah. Plateau when it's above what? Right, which is 5 on 12. Okay? Now, but I'll show you, but how fast are we done? We write down the values for now. 0.75 volts as the amplitude. 0.75. And the maximum and minimum Vn is plus and minus 512. How much is 512 again? 0 point what? 5 over 12? That way you want to say? 0 point what?
0.417.
0.417. Last thing I'm going to finish, right? I just want to go over one of these because I didn't put it in the review. Pardon? Right, so what you see here? So basically you have a sinusoidal input. And the maximum value is 0.75. That's the voltage, right? Minimum value minus 0.75. Okay with that? Nice. So that's the input. But if the input is more than one value, we said 0.41. So you're 0.41. I mean 0.41, 42. Wait, Pete not here. Pete's real quiet boy. I didn't realize that.
Yeah, I have it.
And Darion and he don't come on up. Right, question. What you say? What happens in this part that's above 0.42 or below minus 0.42? Too big, right? Those values called saturation. So when it saturates, so remember I told you what to do? Wherever these two lines, this solid line and broken line meet, draw a line down. Draw a line down. Right, watch here. Everything okay here? Everything okay here because this value below 0.42. But once you go above 0.42, saturation. So the part before here, a little straight line there. Right? Everything okay here. But once they go below, saturation. Connect it up here. Saturation, saturation. And you connect it up. Okay? So it looks like this. Flip it. It shows that you clip off this, clip off this. There's sometimes called clipping. Write it down and tell you. I'll take a picture, you're not gonna enjoy it in your book. Right? Alright, online. So that brings us to the end of our pumps. Next day we do the last part of module 2 is called AC theory. I didn't do it in the holiday, huh? No. AC theory. No? Right. It's dull.